Hi, welcome to another video. I'm trying not to laugh. Have I gone nuts? What has Kellogg's Crunchy Nut got to do with electronics? I'll show you. Here's the bottom of the packet. Have you ever noticed on newspapers, the local newspapers, or different packaging for different suppliers? What do you think they are there for? The answer? This orange, which probably isn't represented properly, this camera and this LED white light. This orange is a corporate colour. They don't own this colour, but this colour represents Kellogg's. Every box gets printed with this colour strip, and so from the first box to the, say, 10,000th box, the first box orange has got to look like this, and the last box has got to look like this. Hundreds of thousands of boxes a day, maybe more than that. Many printers still have 4 inks, and you get the colours by mixing various colours, as you probably all heard of. Older printers, you have to take one, say, box off the pile, go and put it under a scanner and check it, and an electronic sensor checks these colours with an internal reference and compares it to those already programmed. If it sees these colours are fading, it adds more ink automatically or takes the ink away. So that's what these strips are for, to calibrate the printer. How do you get electronics to read these colours? I'll show you. Right, so here we have a stripped down scanner. If you've ever looked inside a CD or DVD drive, you'll know the laser scans the CD from the centre outwards. This is the same. So this is a stepper motor. It moves the light and light sensor up and down to find the colours on your sample print. And whilst I was upstairs in the bathroom, Colgate opened the packet, more sampling colours down here. So the centre of this scanner will move up and down on its internal rail to find these colours, which will be pre-programmed on the computer. The print could be like 60 centimetres wide, so this slides up and down on a linear rail, simply driven by another stepper motor. Simple as that. How do we sense these colours? This is a bit like Blue Peter. Here's one I stripped down earlier. So you've got 3 tungsten lights. 3 tungsten lights shining down onto your colours. The light is reflected back up through this tiny orifice. So this bottom board, a simple regulator to control the current of these bulbs. So 3 simple tungsten bulbs. Simple regulator, so nothing complicated here. I'll use this older board for demonstration purposes, since it's easier than this bigger one I'm going to demonstrate. 2 light sensors. Here is a wheel with different colour filters around the outside. One lot of light is filtered by this wheel that spins. I don't know how well this camera is going to pick up the light coming through these filters, but you've essentially got red, green, blue and violet. They all look like mirrors in this light, but they're colour filters. When this whole unit is manufactured, the light at varying frequencies, so measured in nanometers, so violet is 400 nanometers, red is 650 odd, 665. So red is here, violet is down here, then you go into ultraviolet. So this unit is calibrated at the factory. The computer that runs the scanner, you simply program these numbers into the computer. When light is put onto these colours, on these or the Kellogg's, the light reflects back up onto these sensors, and at least one lot of light runs through that coloured wheel. Because it has internal references programmed at the factory, it knows what colour it's looking at and the intensity of the colour. I think the light goes through the coloured filter just on one sensor, and then the other one's a reference. As I say, the whole unit slides up and down a linear rail controlled by a simple stepper motor, but at the very beginning of the rail there is a black and white spot where this unit does its self-calibration when you first turn it on. It makes sure the white is still white and the black is still black. These are two analog to digital converters. So that's easy, just converts the voltage these pick up, convert them to a digital signal and send them to the top board, which is full of slow, old microcontrollers. These chips, for example, they run at 20 megs, 20 or 32 megs. These are really old and really slow, but they're popular since they're used on a ton of equipment, so they're still manufactured. Chips with labels are programmed controllers. I think these big ones deal with the communication via UART to the PC. I think this one's a memory. I think one of these chips is a UART controller. I forget which one. It's all about converting the analog, very small change in voltage, converted with two analog to digital converters to a digital signal. We can store it in these chips and then pass it to the computer. So that's all this head consists of. This overreads, so we've got about 3.2, 3.3 volts on that controller. So at the moment you can see the scope. We're down in the noise floor. I'm measuring directly off the back of one of these light sensors. In fact, you can see me putting my hand over. So here's two light filters of some LED lights I've got. Our light source is this LED light. If you watch the scope, so this is the white light. If I turn the light off, it drops down to 415. Now I've turned the main light off. It's dropped down to 400. Right, so that's roughly our reference, 403 millivolts. When this unit is assembled, those sensors are in a housing, so no light can get in other than the reflected light off your print. So we've got 463 millivolts, 20 millivolts of division, so we're right down in the noise floor, hence the noise. But so if I put this red filter over the sensor, you can see it drops down to 429. Now if I put this blue filter over the top, 437. Now if I put both, 409, so that's cutting out a lot of light. If I show you, have a look at this spinning wheel, you can see all the light filters. But this spins very much faster than this when it's running properly in the circuit. So now you can understand the internal stepper motor will move this over the colours which have been pre-programmed into the system. Then it moves up and down the linear rail checking the colours. And back to our crunchy nut, this would be sliding up and down checking those colours. So that's it. You've now seen how Kellogg's and Colgate meet the world of electronics. Hopefully you've learned something, hopefully you found it interesting. I'll say bye bye and thank you for watching.